We know that if we have a system of linear equations, we can solve that system by graphing it and finding the intersection of the two lines. There's also a way we can solve for that intersection point algebraically by using a method called substitution and another method called elimination. Today we're going to look at substitution. The steps are as follows. First, we're going to isolate for a variable in one equation. And as a hint, we solve for whatever variable is more simple to solve for. Then we're going to substitute that expression that we figured out in step 1 into the other equation. In that way, we can solve for the other variable. Then we take that solution for the other variable and substitute it into the variable we isolated in step 1, and that way we can get both variables. Then we test our solution. And it all sounds weird right now, but when we go through examples, I hope it gets clearer. So let's look at this first linear system we have. One equation is x minus 1 equals 6 plus y, and the other is 2x plus 5y equals 21. First step is to isolate for a variable in one of those equations. And the hint is solve for the simpler variable, and meaning what's the easiest thing to solve for. I'm probably not going to choose to solve for anything here at first because you're multiplying by 2, you're multiplying the x by 2 and you're multiplying the y by 5. It's just going to take more work to isolate for those variables. So I'm going to choose that first equation for my step 1. X minus 1 equals 6 plus y, and I can choose to isolate for either x or y. Doesn't matter. I'm going to choose to isolate for x, and I can do that by adding 1 to both sides. So if we add 1 to both sides, we'll have x equals 6 plus 1, which is 7, plus y, or y plus 7, okay? So at the end of step 1, we have this. Step 2 says, take that expression now, because it's isolated for a variable, and plug it in to the other equation. So you have a solution for x, and you're going to substitute that into the other equation. Okay, so what we'll have is 2 times x, x meaning y plus 7 here, plus 5y equals 21. From this point, you can solve for y. So how do we do that? We have to multiply through these brackets. So 2 times y is 2y, 2 times 7 is a positive 14, plus 5y equals 21. Add like terms, 2y plus 5y is 7y. 7y plus 14 equals 21. And remember, the goal here now is to solve for that variable. So what we'll do is subtract both sides by 14. And I can do that here if I have room. And what we'll get is, here, subtract both sides by 14. What you'll get is 7y equals 7. And then finally, divide both sides by 7. Divide both sides by 7 to isolate for the y. And you'll get y equals 1. Okay, you have y equals some number. You've solved the y part of it. Now that you solved the y part, go ahead and substitute that value of y into the first equation. And you've already isolated for x in the first equation, so you would substitute it in there. And now you'll have x equals y, which we just said is 1, plus 7. So therefore x equals 8. Okay, so that's your solution. Your solution is x equals 8, y equals 1. Or you can say your intersection, or your solution to that system is 8, 1. If you're talking about writing the solution as an ordered pair. How about testing? Testing means you would plug those x and y values in both of the original equations and make sure those equations work out, that they remain true. So I'm going to do the testing up here. And I'll call this equation A and this one equation B. Okay, so for equation A, x minus 1 equals 6 plus y. What we'll do is we'll substitute the 8 for x and the 1 for y. So we'll have 8 minus 1 equals 6 plus y, which is 1. And what does that turn out to? 8 minus 1 is 7. 6 plus 1 is 7. So the equation is true. So that solution worked for that equation. 7 does equal 7. If we do that test for equation B, you have 2x plus 5y equals 21. So 2 times the x value of your solution, which is 8, plus 5 times the y value of your solution, which is 1. Does that equal 21? Let's see. 2 times 8 is 16, plus 5. Does that equal 21? Yes, 21. 16 plus 5 is 21. That equals 21. The solution works out for both equations. That means our test is good. Our solution is correct. There was a lot going on here for this method of finding a solution. So you might want to rewind and go back to this example before moving on to the next one. Next example, we have two equations that form our system. We want to find a solution to it. If I'm looking to isolate for one variable, it seems isolating for this x in that first equation there is probably the easiest thing to do, because all I have to do is subtract 2y from both sides. So if I subtract 2y from both sides of that equation, I'll end up with x equals negative 2y plus 13. And that is the end of step 1. I should call this step 1 here. Step 2, substitute that expression into the other equation to solve for the other variable. So now that I have an expression for x equals something, I can take that and substitute it in. I'll go this way. Substitute it in to the x value, to the x variable in the other equation. So step 2 here. We have 2 times x. Well, I've solved for x. X equals negative 2y plus 13. Add that to 3y, and the equation says that equals negative 9. We want to solve for the other variable now. We want to solve for y. Okay, so let's multiply through these brackets. 2 times negative 2y is negative 4y. 2 times 13 is plus 26. Plus 3y equals negative 9. The goal is to solve for y. First, let's add like terms. We'll have negative 4y plus 3y is negative 1y plus 26 equals negative 9. So next step would be to subtract. What I'll do is I'll add y. I'll add 1y to both sides and subtract 26 from both sides. As a result, I will have, add y to both sides and add 9 to both sides. So what that'll do is y goes away on the left side. 26 plus 9 is 35. And then on the other side, negative 9 plus 9, that goes away, and you're left with y. So you've solved for y. Perfect. What do we do now? Now that we solve for that variable, step 3 says substitute that solution to the variable found in step 2 and determine the other variable. So we want to stick this y value in for the x over here from step 1. and then we can solve for x. To be clear, we're taking this y and we're substituting it in right there. So we have x equals -2 times our y value that we found, which is 35, plus 13. So we have x equals -2 times 35 is -70, plus 13, and that then would equal -57. So that's our solution for x. So x equals -57, y equals 35. You can leave it like that, or you can write the solution as an ordered pair. We need to test this out. So let's test. We have equation A and equation B. For equation A, I'm sticking in those x and y values that we found into the equation and making sure that equation holds true. So x, which is -57, plus 2 times y, which is 35, does that equal 13? So we have -57 plus 70, does that equal 13? Well, yes, it does. That equals -57 plus 70 is 13. That equals 13. That's true. For B, we have 2 times the x value, which we say is -57, plus 3 times the y value, which we said was 35. Does that equal -9? 2 times -57 is -114, plus 3 times 35, which is 105. Does that equal -9? -114 plus 105 is -9. Yes, that equals -9. That holds true. So our solution of -57 and 35 is the solution. If we're given 4x plus 3y equals 7 and x plus y equals -1, we can label this right away if you'd like, A and B here. I would say choosing one of the variables in the second equation is easiest. And again, we can choose to solve for x or y first. It doesn't matter. Flip a coin. Hey, let's solve for y first. So we're using equation B to solve for y. So this is step 1. X plus y equals -1. If we want to solve for y, we would subtract x from both sides. And what we would get is y equals -x minus 1. Okay, that's the end of step 1. We have isolated for a variable. Okay, step 2 says take that expression, plug it in to the appropriate variable in the other equation. So that means we're going to take this y and plug it into the y in equation A. So we have 4x plus 3 times y, which is -x minus 1, and that equals 7. Step 3 says, or that's step 2, and what we want to do is solve for x. Okay, so let's expand this equation. 4x plus 3 times -x is a -3x. 3 times -1 is -3, and that equals 7. We want to solve for x. We can add like terms. That's 4x minus 3x is just 1x. Minus 3 equals 7. Add 3 to both sides to solve for the x, and you'll end up with x equals 10. So we have a value for one of the variables. We have x equals 10. What we'll do now is take that and substitute it in to the first expression that we solved for, or isolated for. So we can plug that x into that expression for y, figure out what y should be. Y equals -x minus 1. So that is y equals negative 10 minus 1. Therefore, y should equal negative 11. Okay. It's a lot of work. Maybe I made mistakes along the way. The only way to figure that out is to test the equations. So let's test them out. Testing equation A, we have 4 times x, so 4 times 10, plus 3 times y, 3 times negative 11, equals 7. Okay, 4 times 10 is 40, 3 times negative 11 is negative 33. Does that equal 7? 40 minus 33 is 7. That equals 7. We're good. Let's test equation B. Both equations have to work when you substitute the values you solve for. X, which is 10, plus y, which is negative 11. Does that equal negative 1? 10 minus 11 is negative 1. That equals negative 1. We tested B and it works. So our solution of 10, negative 11 is the solution that works. That is the point of intersection. We have the following linear system. It's just shown in a picture form rather than in an equation form. Let's say this is equation A and this is equation B. What's the solution? Well, let's start by writing these scales here as an equation. So for equation A, you have 3 x's, so 3x plus a y, so that's 3 x's plus a y, equals 10 plus 5 plus 2. That's 10 plus 5 is 15, plus 2 is 17. So 3x plus y equals 17. That's your first equation. Equation B, you have x equals y plus 3. That's your second equation. Now, if you look at this, we know that our first step is to isolate for a variable. Let me write this more clearly. Y plus 3. Our first step is supposed to isolate for a variable, but luckily for us, equation B is already isolated. Right? We already have an expression x equals. We have an expression for x, which is perfect. So that means all we need to do now is take that expression for x, substitute it into equation A there, and then we can solve for y. So what we can do is we can take 3 multiplied by x, which is y plus 3, add it to y, that equals 17. Solve for y now. 3 times y is 3y, plus 3y, and then 3 times 3 is 9, plus y equals 17. Add your like terms. 3y plus y is 4y, plus 9 equals 17. Isolate for the y. Subtract 9 from both sides. You'll get 4y equals 8. And then we can divide both sides by 4. And we'll get y equals 2. Right, so we have y equaling a number. Y equals 2. We solve for y. We can take that now, plug it in to that expression to solve for x. So x equals 2 plus 3. Therefore, x should equal 5. We still need to test this out. So let's test out A. A was 3x plus y equals 17. So 3 times x plus y equals 17. 3 times 5 is 15, plus 2 equals 17. 15 plus 2 is 17. That equals 17. Perfect. Testing B. X equals y plus 3. X is 5, we said. Does that equal a y of 2 plus 3? 5 equals 5. Yep, that works. So it's important to test things out to make sure your solution is correct. But just follow the steps for substitution and that should get you to the solution. Thanks.